Okay, we'll get started with Weather Watch for March 8th. You're subjected to me today because Professor Martin is not going to be here, and I'm not going to do Weather Watch. We're just going to start this loop for 45 minutes. But I'll let this play once more because it's just remarkable what this was all happening. This is one day. It feels like there's literally everything happening in this loop.
Oh, yeah. And then it goes like real dark, right?
Yeah. This is when we had our severe weather, kind of. We didn't get severe weather, but to our south did.
Someone's standing up.
With that.
Really needs a soundtrack.
Yeah, it does.
Pink Floyd or something crazy 60s psychedelic.
Then you can see the wind shift. This is right when I went to the bus, and the wind shifted from the north, and it was 10 degrees colder instantly and windy. And you can see it in the low-level clouds right there.
This is when I was standing outside in the rain.
Yeah. So it was just awful. And we did get a lot of rain, a lot of lightning from this, which was surprising how cold it was, and how we were, earlier in this day, dew points were in the 20s for us. So you don't really expect any, severe weather, real rain like they were talking about. But it rained for a little bit at the start of where you see that wind shift, and I think that was enough to get the ground moisturized enough so we actually did see substantial weather here. But places to our south where they did get severe weather, dew points in the 50s, so kind of a weird setup. And the temperatures were the exact same, 50s everywhere. We were just incredibly dry, and areas to our south were very moist.
Another thing about that day is that the convection was all elevated.
Yeah, that's right.
So it wasn't even surface based. So
Yeah.
Right.
it just needed to be big enough to be able to fall through that dry area.
Exactly. And it just barely does. I mean, I'll wait for it to start raining again, but it's a sprinkle, it looks like, on the camera here.
I'll move it forward a little bit.
Oh yeah, perfect.
I want to show the north-facing one too, because there were some bores or some really
Oh,
interesting
yeah.
wave features that came through after the wind shift.
Yeah, you'll see. So right around here, I was at the bus stop. Oh, it's 50 degrees, it's nice. And then here's that shift, and you can see that just brief rain, but it saturates the ground enough. You can see it, roads got wet, and then was enough. And then we got more rain and our weather. So very interesting. The atmosphere is a fluid, as you can tell by this. It looks exactly like waves. And then we'll get a look at the north-facing camera too here. You can see them working on the data science school.
Yeah, I got to update my time lapse of that too.
Yeah.
Start from the beginning.
Oh, yeah, you can-
Just wait, it gets better.
Whoa, you see that around the lake?
No, here comes the wind shift.
Yeah.
But then there was
Oh,
one,
yeah.
there's one,
Huh.
there's one.
Someone needs to go squeegee this so you
Yeah.
have a better view of
Right.
what's happening.
That's pretty much it.
Very cool. Thanks for grabbing those, Pete. Can we start with the IR loop, the week-long IR loop, please? So as is typical, a lot happened over the past week, and I'll touch on some of these events here. Starting off with, we'll see it at the very start of this loop, so I'll draw your attention to California right here. Sierra Nevada's got 10.5 feet of snow, winds up to 190 miles an hour, and people live there. There's resorts there. So it's not just you're on top of a mountain, of course it's weird weather. People were living there and had to undig cars. I mean, if you warn for 10 feet of snow, you hope people don't drive, but that never happened. So people drove, and then they had to be unburied and created chaos. But some ski resorts went from, low levels of snow, no fresh powder, to here's 10 feet on top of what we already had. We don't even care about what happened before because now we have snow into April, almost guaranteed. And it's that big fire hose just at the beginning of this, which I'll point out again once more at the start here. And it's this little notch of California right there. And so you have winds just slamming into the mountain, upper level winds. So that's enough to create lift. You're in the cloud because you're so high up, and 10 feet of snow in 2 days. And then could we pull up that video?
Yeah, John was talking about maybe 200-mile-an-hour winds up in the Sierra. I saw odds of 190, so it was pretty close.
And I think that was pretty close to the state record for California of the highest winds ever recorded. And this is what it looks like, so.
I think the sound did work, but
Yeah,
if you actually listen to it.
Jeez.
Is it upward falling snow?
yeah, right. This looks like you're on Venus or Mercury or whatever.
It was in the Sierra, yeah. It's
Yeah.
right there.
Camera error.
I know.
Camera error.
Yeah, can somebody go repair this camera, please?
Hi.
Yeah,
Okay,
it's sort of terrifying.
Yeah. So just imagine skiing here one day and then the next day you see this when you're checking out the ski conditions. So just wild that this happened. And then, so that's California. Then that same trough system that you'll see at the beginning here. So it's one big trough, cold air. You'll see it slowly propagates over the mountains. We get a development into the northern parts of the States and Canada. Along that, here's a warm front. Here's your storms for Monday night. They sort of flared up right over us. Places just to our north and west got no rain. Places to our south and east got 2 inches of rain. So we were in the sweet spot. We got a little bit of rain from it. But luckily, we got to see the thunder and lightning and not just rain. So we got bang for our buck. And you'll see that system, as it forms, it kind of moves into Canada and lingers, and we were beneficiaries of the warm front of it. So you see there's the flare up, and then the system is just kind of dies out over Canada. Oh, and there was severe weather reported in Rock and Walworth counties, so winds and hail. There was one tornado in Illinois. So again, this part of the country has been having a lot of tornadoes for this time of year, which is very bizarre. Seems like every week now we're getting tornadoes here, and nowhere else for the most part. It's been really localized to our region, and then Michigan and Illinois, Indiana, and Ohio. The next feature, which comes up right here, we have a developing low pressure system, and it kind of lingers over the northeast. And I'll point that out again here. So it's not this moves away, but it did saturate the ground. You'll see here's our system. Here's this developing feature, lingers along the coast, still is lingering, kind of gets picked up by another feature, and then you get flood watches and warnings along the eastern part of the United States. And these are heavily populated areas, a lot of concrete, so they don't need a lot of rain to get flooding. So they had a lot of flooding issues from that system. What else? And then at the very end here, which I'll let it roll over here, we have that drop feature move away. Here's your northeast United States system. You can see, kind of make out the upper level flow pattern over the Rockies, and we have development in the lee of the Rockies. This system right here, which is bringing our rain today, perfect. Can we go just back a little bit, maybe to, yeah, that's perfect. So this is all rain, but the portions in Nebraska, Wyoming, Colorado, Kansas was snow. Denver and Boulder got 3 to 4 inches of snow. North Platte, Nebraska, which is roughly right there, had 15 inches in one day, which is the record, set in March. It's kind of weird, but this is pretty typical for late season snowfalls for portions of the Mountain West. Luckily, I don't think we're going to be in the snow. We're going to be in the rain. But you can kind of see it's kind of a dilapidated system. All of this being snow, and then out ahead of it being rain over our region here. So still winter back towards the west, but it seems like we're stuck in the spring-like pattern, which is nice, we get to be outside and not have it be cold and snowy, like it is, and it's been going from, it'll be 70 one day, and then it's 30 the next day, and snowing, you have 15 inches of snow, and then the next day it's 40, and then 70, and all your snow is gone in one day. So did it even snow? I don't know. Not a lot of people live here, but it's just interesting that, the temperature swings that are going on there. And it seems like it always happens over the western part of the United States. And then here's our rain. It's kind of hard to make out where the center of the system is from the IR loop because it's all just, spread out, linear features. It's not really as pretty as, like a classic comma shape for a low pressure system. And then at the very end here, you can make out something else is brewing off the coast of California, which we'll see in the upper level charts. But that's probably the next weather system. It might be another round of heavy snow for California, which is good, helps with the drought, but the people who are stranded are getting unstranded, and then they might be stranded, a couple days later. So hopefully they're watching this and learning from their lessons of driving in 10 feet of snow, which is just bizarre. But that's aside. Could we go to the super peaks, please? Oh wait, no, sorry. Could we go to the springtime animations?
Animations?
Yeah, I think, or just these images are perfect. Yeah. So this is a map, thank you, Hamish, for passing these along. This is a map from the National Phenology Network showing when woody plants are leafing out. And they classify it by the time it takes for these woody plants to leaf out, and then they're measuring, is this early for the period of record, or is this late? So early in red, late in blue. What you can see, portions of the far south portions of the United States, this is actually late for their spring by a little, a couple days. But everywhere you see this dark red, this is record early spring. And so you can kind of see, this is an animation and it just slowly builds. It's like a growing vine or something, and it comes up from the south to the north. But all these portions of Missouri, Kansas, Illinois, Iowa, Nebraska, these are all the record earliest spring for that part of the world. And you can imagine this might continue. We've had our warmest winter ever, Minnesota and Wisconsin, and so this is your consequence. You get spring early, and then you have spring right here, and right here, 100 miles away, you get 15 inches of snow. So you can imagine the crop damage that might happen when you get trees leafing out, flowers leafing out, crops beginning to grow, and then send 15 inches of heavy wet snow on top of that. Not a good thing if you want to grow successful crops and keep your flower bed looking good, but as this continues, we can check up on this weekly and see we'll probably be in a record earliest spring for our portion of the country. And I can imagine most of the upper Midwest would also be in this early spring, as is already the earliest spring to our south here. And then there was one other.
I had them as images. Were they supposed to be animations?
One of them animated. I don't think it really necessarily matters. You just see it kind of propagating northward. But yeah, so here's that classification. Everywhere in the darkest green is the earliest spring on record for this portion of the country, and then also into California in the mountains where 100 miles away, again, you get 10 feet of snow in 2 days. So this will be something to watch. We might see, allergies creep up on us here in a couple weeks, and we're changing the interface essentially of what's happening with plants and humans because it's been so warm for this year. So something to watch for sure. Earliest spring on record, and we're living through it, which is kind of cool. In a weird, way to say that's cool. Yes, okay. Could we go to the upper level charts, the 500 hectopascal, please? So we're going to look at the current troughs and ridges. And you'll see here. So there's one dominant feature of the United States, and it's this big trough, kind of like a bowl-shaped trough. very wide. It extends almost the entire portion of the United States. Here's that little ridge that brought us our nice spring-like 50-degree temperatures for 2 days. You can see how small it is, so it wasn't a long-lived heat wave, but now we're back into this troughiness. You'll notice from the IR image, this was where we had all that precipitation and cloud cover, and this is where you see that upper level divergence because you're downstream of a trough. So that fits exactly, but because it's such an elongated trough, you don't have a nice sharp, curvature maximum, so you don't see that nice sharp low pressure center like you would with a trough like this, where it's nice and sharp. And then right in its heels, notice two things. We have another short ridge compared to this trough, and then another trough feature. So this is your next weather maker in California, and this might be our next warm-up after this trough lumbers away. And then one thing that's interesting is we see the Hudson Low. This is a climatological feature. You have a big ice sheet, and you're in Canada, so you don't get a lot of sun in the winter. And so you're constantly cooling the air above this big lake mass, and you develop low heights, low thicknesses, low heights. And so usually you see a low pressure, trough over Hudson Bay over the winter time. And because it's been so warm, we kind of haven't seen this low, linger over Hudson Bay. It's been dislodged multiple times, but now we see it back over Hudson Bay. So that's something that you typically always see in this part of the country this time of year, because it's just such a big ice sheet and it's just constantly cooling above it. I believe that's all I wanted to point out for this. Can we go to 850, please? So we're going to look at the temperature advection across the country, and especially over our region. So one thing to point out, we are now below zero at 850, which usually corresponds to being colder at the surface, and that's exactly what happened. You can see in that trough, or in that ridge, 850 temperatures are fairly warm compared to what we are, and so that was your spring, 2-day spring, and then we're back into this like spring-winter mix, 40 degrees and rainy, kind of gross. And you can see a decent trough, if you could call it that, with a cyclonic wind shift, but it isn't exactly organized because that upper level trough is not exactly organized either. So this is more where you would expect your low pressure center to be as it's closer to the surface, but it's pretty dilapidated comparatively. And you can notice also all of the warm temperatures are way down to the south into Florida and Texas. Most of the country is fairly cold at 850, and there's lack of clear temperature advection aside from being well into the south, where you go from 20 degrees at 850 to 13 across Texas, and then with due southerly winds, and then everywhere else it's kind of just parallel to the temperature lines, not a clear advection signal. And then it gets messy over the mountains, and then we could expect cold advection based on the temperature lines as this feature moves into moves to the western United States. So you could expect another round of snow for the mountains, and then messy weather for the west coast of the United States as well. I think that's what I pointed out here. Can we go to the surface now, please? So we'll get a better look at where that low pressure center is located based on the station plots, and then what we might expect for today's weather. So you can see, you can make out a pretty decent cyclonic wind shift with it, although there's not a clear minimum, and this is probably your minimum in sea level pressure, 1009.5, but it's not a clear, tight, closed circulation. It's a general cyclonic circulation. You can see the snow in the lee. So this is North Platte, Nebraska. You can see some snow in central Nebraska and Omaha, and then into the mountainous portions of Colorado, Wyoming, some in Kansas. And then you can see the wind shift as it's northerly all the way down into Texas, and then southerly out ahead of it. And that's corresponding to warmer temperatures out ahead and colder temperatures behind that feature as well. And here's our spring temperatures that we had in the 50s and 60s. Just awful weather compared to what we're having. I mean, 61 and light winds, just sunny is terrible. We're here in 43 over 40. it's moist, it's raining, winds slightly out of the north, so not exactly the best day to be outside. But it's nice to get some rain, as we haven't had a lot of rain around here. You can notice too, definitely a frontal feature of some sort as the winds shift 180 degrees and there's a clear temperature and dew point gradient along that shift as well. Right there. And then I think that's all I wanted to point out here. So now we'll go into a little bit of the forecast. Can we go to our 104 grid? And we'll start with the surface at 12 hours. This is a look at this evening. So you can see we're still in that rain from this low pressure, forecasted to get down to 1,007 by this model. And you can see in its wake, we have the imagined cyclonic winds around this low pressure. We have cold air advection based on the thickness lines and the flow of the surface wind. So in its wake, it will get colder, unfortunately. So it'll be a couple of days of gross rainy weather, and then because of what's forecasted as well. And then you can notice our warm-up too, that's also forecasted in the thicknesses as they, the same thickness line that's all the way down in South Dakota is well into central Canada. So here's our little over the weekend cold snap, and then we have a warm-up following that as well. But that's foreshadowing just from this look here. Can we go to 500 at the same time? Please? Maybe I should have started with that. And you can see our dilapidated trough with the vorticity maximum around it. The only issue is you don't have a nice signal of, a nice ball of vorticity followed by low vorticity, like in this trough here. It's kind of just one strip around the base of the trough. So we don't get a clear signal for positive vorticity advection by the thermal wind, strong rising vertical motion, as you would with a trough that's short and stubby and has a nice gradient of vorticity. So that's also a reason why this system, even though it's bringing sensible weather to our region, is not exactly the strongest feature as it could be if it were associated with a trough like this. You can also notice here's your Hudson low, here's your cold snap based on this trough that we'll see, and then you can see the ridge building just in the wake of this trough as well, and then here's your mess that's going to come into California here. Can we go 12 hours in the forecast, and let's do 500. Let's stick on 500 here. Still dilapidated, this trough. Maybe there's some gradient and vorticity out ahead of it, but it's messy. We can see at 500 our winds become northerly, and this is looking at tomorrow morning. And we'll look how it looks at the surface here. There's a trough well to our north, so we might not get any sensible weather from this trough, but there'll be that lingering low pressure system. Your ridge becomes more defined in its wake, and it seems like it gets a little stronger than it was. And then here's your system crashing onto the California coast here. So let's look at the surface for the same time, please. 24 hours in the forecast. You can see from the thickness lines, and then if you imagine anticyclonic flow around this high pressure system, we're in northerly winds, fairly strong for tomorrow morning with cold air advection. So it might be a nice morning to sleep in tomorrow, I would say. With it rainy, it'll be damp, we'll have cold air advection, it might be cloudy because we're still in proximity with this low pressure system, so might be a reminder that it's not exactly spring here. And you can notice just in its wake, here's that ridge and high pressure behind it. And then rain beginning to be forecast, maybe even some snow along the California coast as that system makes landfall here. Let's go to 36 hours, please, and we'll go to 500. This will be Saturday evening. You can see this trough feature becomes even more dilapidated with the strip of vorticity is kind of just being left behind as this trough moves off to the east, and is kind of being superposed with that trough that was coming from Canada as well. Maybe some influence of the Hudson low and the vorticity associated with that. Interesting ball of vorticity, almost looks like a hurricane in the vorticity at 500 here. You can see very strong gradient of vorticity out associated with that system over California. So you can imagine, we'll look at the thermal wind, but imagine a lot of rising motion from PVM and the thermal wind. And then our ridge has slowly moved off the western United States and is beginning to influence our weather, it seems, at 500 here. So could we go to,
I see kind of a googly eye face on there where there's an eye, there's a nose.
oh, I see it, yeah. Like a clown makeup.
Picasso face or
Yeah.
something.
That's funny.
Anyways. Melissa probably.
Glad to know you're paying attention to my presentation. Again, tomorrow evening, we're still in that cold air advection, unfortunately. So maybe all of tomorrow might be a good day to sleep in and stay in bed if you're able to. And then you can see exactly where we saw that gradient of vorticity. There's a decently strong thermal wind, and you can see right where that gradient and thermal wind coalesce. You have the maximum precipitation. A lot of this is probably just you have flow off the coast of the United States, or sorry, flow off the Pacific Ocean into the mountainous regions, but here's your main feature associated with it. It's low, now 985. I was not paying attention to what it was earlier, and our system is largely becoming, stretched out as that trough was kind of also being stretched out. Maybe it looks like even reforming to the north where you had a stronger signal in that vorticity in that trough. And this is the sort of, end of the system that impacted us at the same time. And could we go to now 500, 48 hours in the forecast. So this will get us to Sunday morning now. We can see maybe there's some reformation of this trough that's now beginning to look way more impressive than it was, just a day ago. A couple little vortex max in there. That strip of vorticity that was sort of driving the bus for our weather is just being left behind again. And you can notice with the system making landfall on the California coast, again, a really strong gradient of vorticity where you go from, high values, maybe 3 times the Coriolis force to nothing over the Oregon and Washington states. So you can imagine, we'll look at the thermal wind, but a very strong gradient of vorticity again will create a lot of vertical motion and rain and snow and messy weather. Luckily, it looks like this system is not in close proximity to where they just got hit with a ton of snow, but it still is enough to potentially force some lift over, the Sierra Nevadas and California as well. And maybe this lobe of vorticity might swing around the trough, but I'm just speculating now. Could we go to the surface now, 48 hours in the forecast, Sunday morning, and we'll see if that's the case. Yeah, so for that system, you can see right along where that gradient was strongest, it's sort of, it's creating a lot of lift, but then you're also getting flow off the ocean into the mountains, and so that's kind of a double whammy for lift. You create probably pretty high amounts of rain and snow being forecasted for the northwestern portion of the United States. We're in a high pressure extending most of the central part of the United States. Maybe we were in cold air advection before, but now we're kind of in no advection. We're just sitting with cold thicknesses over us. But just to our west, you can see this nice ridge that'll bring us very warm temperatures comparatively, and that's extending all the way up into central Canada. Looks like the influence of it actually goes maybe all the way up to the Arctic Circle. You continue that. So this is a pretty interesting feature, a very high amplitude ridge, you can tell just by the thicknesses. And as those troughs sort of reform and become more impressive, you can see this development now is below 990, it looks like, and it's beginning to strengthen as well and produce more rain over the eastern portion of the United States and into the northeast, which they just had rain, so they don't necessarily need this rain maker that it looks like it will be for Sunday, maybe even into Monday here. And then could we go 12 hours further? So go to 60 hours at 500. Just look at the end of the weekend here. So yes, this is a very nice trough compared to it was just a couple days ago. You can see a nice strip of vorticity with a maximum around the base of the trough, and then largely weaker vorticity out ahead of it. So you can imagine there's very strong gradient vorticity. We'll look at the thermal wind, but this is a nice signal if you want upper level divergence out ahead of where that this trough is located and right over where that low pressure center was at the surface. And then another nice signal here off the California coast, very strong vorticity going into no vorticity. And we'll look at the thermal wind, but you can imagine it flowing and affecting this vorticity gradient and producing a lot of lift. And it looks like some portion of it is now getting into the Sierra Nevadas in California as well. And then here's our ridge. That looks like it's going to bring us 60s going into Monday and Tuesday and Wednesday. After a weekend of 40s, which will feel really nice. I mean, 40s for March is still above normal, but with the winter we're having, that seems cold now. So, this will be a nice, spring, if you want to call it, 60 degrees. It's kind of remarkable that that's spring. And then there's still that strip of vorticity, very oddly, is just sitting over the southern portion of the United States, not really moving as it has in a couple days now. We go to the surface now at 60 hours. So yep, we have two regions of precipitation right where we had those gradients in vorticity, very strong thermal wind, so you can imagine the advection of that vorticity, right over Maine into Nova Scotia, and then into the western portion of the United States, and now making its way into the Sierra Nevadas as well. And we are now in thicknesses, warmer thicknesses, as this is I believe the 540 line, and which was well off to our west, and we were in the lower thicknesses, which is now centered over Pittsburgh, it looks like, for Sunday evening. And then we're still in this high pressure region, so we might expect a lot of warming on Sunday, sunny skies, it'll feel much nicer, the winds will be weaker, and then going into Monday and Tuesday, we'll watch the thicknesses also increase for us as well. So now can we go 24 hours, and I'll do 500 first, and we'll just briefly step through the week going into Friday. This trough feature looks way more dilapidated than it was. Very messy. There's some regions where you could maybe argue for a gradient vorticity that might be affected, but largely it's just one big trough feature with many vort max. So this system might be expected to weaken based on that. And as well, you're kind of losing that pretty strong signal we had over the west coast of the United States. Still a decent amount of vorticity gradient, so you would expect some fairly decent uplift as well. And then it seems to be something brewing over the portions of the United States. This might be a lee side trough beginning to form. So you can see the dip in the geopotential and then an increase in vorticity as well. And it's very largely matched with the orientation of the Rockies as well. So that might be something to watch. But usually when that happens, we get warm. And so let's see if that's the case for 84 hours. This is Monday evening we're looking at here. Yes, that is absolutely the case. So our thicknesses have greatly increased. Even the models are hinting at lee-side cyclogenesis, but no precipitation with that, so maybe it's just too dry. I'm not really sure of that. But thicknesses have increased over us. We're in the 60s now, maybe some winds from the southwest, so it feels very nice. More like spring and maybe even early summer for us. You can see the nice region of precipitation still occurring over the western portion of the United States. And then this system is becoming more broad and spread out. Still a decent storm, 971, just off Maine. Here's Maine, and here's Nova Scotia and Newfoundland and everything. So some of this precipitation definitely going to wrap around and affect portions of the Northeast. But we might expect this to weaken, and this might be the strongest of this system as well. And so let's step through, let's see, 24 hours. Yeah, perfect. Nice bullseye of vorticity right in the center. of that trough feature. Now it's becoming more cut off, it looks like. Here's our ridge, bringing our nice weather, kind of messy vorticity, and maybe there's a trough over the western portion of the United States, but largely we have zonal flow from west to east. And so you have zonal flow, you'll have warming occurring with adiabatic compression off the Rockies, and so we might expect to be warm and stay warm, and we'll see if that's the case at 108 hours if we go to the surface. And yes, it looks like that's the case. Our thicknesses are still warm. Maybe we get some rain for Wednesday evening, but looks very weak. Or sorry, Tuesday evening, looks very weak. This system has weakened. It's kind of taking on a couple, maybe low pressure centers as well. And the precipitation is finally ending for the western portion of the United States as well. And right on its heels, it looks like another system, which is typical, but you have rain and snow lasting for several days, 1 day break, and then another system. That's not exactly manageable for those parts of the United States. If we could step forward 24 hours ahead from this one, please. So this is Wednesday evening. Now we have a trough feature. This almost looks exactly like what's happening right now, where we have a big trough dominating most of the United States. Some upper level divergence out ahead of it. We might see if there's a low pressure forecast to develop. I won't touch on this because it looks like this system is largely beginning to weaken and move off into the North Atlantic, and this seems to be the major feature. Next weather maker potentially, so if we could go to the surface for 132 hours, please. Maybe there's something developing. It doesn't look very robust from this look, but there might be some precipitation beginning to develop from this system. And then if we could let's just step through at the surface, 24 hours from, that. Perfect, so I don't know if I really trust that there's something beginning to develop. It was kind of, in Kansas and Oklahoma, and now it doesn't seem to be there, but might be some. We have that trough feature. You can make it out in the thicknesses. Out ahead of it, we might be beneficiaries of some rain, but it doesn't look anything heavy like it could be if this were to be a decent, strong development for the middle and eastern portion of the country. And then I want to end, can we just go to weather.gov? Please, we'll just get a look at the forecasted precipitation. All liquid. So if we could scroll down to outlooks. Let's see, current outlook maps. And then QPF, quantitative precipitation forecast, and then we'll just do the total. So right where we might expect bullseyes along the west coast of the United States and then into the northeast. We're forecasted to maybe get close to an inch of rain, but largely we remain dry, and east coast stays wet, west coast stays wet, middle part of the country stays relatively dry. So that's all I have to present, and I know I say all I have as I almost took up most of the time, but anyone wants to look at, or questions or anything like that before we break? Perfect. Well, thank you, Pete. Thanks for coming.
Patrick.